So take this Unreal part with a grain of salt. I'm really junior in Unreal, but I will learn it. Okay, anyone knows who these two guys are? Yeah? The right guy. The right guy was, he's called Stevie Williams, and he was a CG animator on Terminator, Abyss, and Jurassic Park. And decision to do Jurassic Park was to do it with stop motion, to do dinosaurs with stop motion. And this guy animated dinosaurs in 3D on his own. And heads of ILM were pissed off at him, like, you don't do that, we will do it in stop motion. And Caitlin Kennedy saw his dinosaur, showed it to Spielberg, and then decision was made to do it in 3D. So he was expecting to become animation supervisor, but this guy, Phil Tippett, became his boss. And Phil Tippett is like a guru of stop motion animation. There is really good documentary on Netflix about that story. Why is it important to us? Because we all are going to be replaced by AI. So I'm showing you stuff that can be easily generated by AI now. So yeah, if you think like that, go out. Okay, so Richie and me earlier were showing some of this stuff. So this is our in-house passion project called Rava. It's about World War II ship that sank on this day, actually. So we had almost zero budget and a really good spirit, and it was really good testing ground for us to build the whole environment pipeline. And I was responsible for that, and my decision was to try to do it with USD in Solaris. So these are some breakdowns. I held a lecture on Hague event, international Hague event last October about this. So like this presentation is not going to be so technical as that one. Yeah, so that was Drava. This is the other project. I cannot tell you which it is because project never closed. So our task on this project was to create 5th century Jerusalem. So using, for example, some program like Cesium, which is really good for like scraping maps data and creating environments, doesn't make sense because like you can get environment which is contemporary, but for something from 5th century you have to be a bit artistic. So on this project, we had Grand Bazaar assets that we bought, and we created some of our own assets, like these like hero churches, temples, towers. Some of these we destroyed for the final set dressing. Yeah, and we had some trees as well. Yeah, these are like, we had much more assets. I couldn't show all of them. We had around, I think, 80 assets in total, and some of them were like asset assemblies. Okay, so this is the other shot from that project. So it's 6th century Mecca. So we got, from historians, we got like a small model of the thing, and we had to recreate a whole terrain for it. And yeah, we have also night versions of this. So all of this we assembled in Solaris and rendered in Karma, and this was age of Houdini 19. And at the time, our pipeline was tied to Python 2. So like, even though Houdini 20 was a thing, we were forced to use Houdini 19 for this. Yeah, so I'll guide you through the process how we created these environments, like what are the essential steps. This city is called Kufa. Yeah. Okay. 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 So the first thing is getting the data. Like, should we try to sculpt it artistically with height fields, or try to get data from some of the sources that you see here? So, for example, this is a plugin called Mapbox. It's part of Houdini Labs suite, and you can see like what is the difference between 3D scan and Mapbox. So Mapbox is very unprecise. So for example, here for Belgrade, you get 1 pixel per 50 meters. So this is really not sufficient to, let's say, describe some of the steeper streets in the city. So what we had to do is we found the model of Jerusalem, and then the task was to get rid of the trees in this model. So we used a bunch of like data manipulation in order to get rid of this kind of stuff. And nowadays, like if you want to do this kind of stuff nowadays, if you use reality capture can actually, you can use segmentation model to detect the trees and interpolate the zones where trees would be. Okay, and for this, for Mecca, these are parts of Mecca. We did like 3D scans of this. So we created a bot that would go in Google Earth and do print screening like around these mountains and take this to reality capture and create models of it. And you will see what is the difference. So this is input 36 kilometers map, and this is how it looks when you project these like 3D scan tiles into it. So you just have to figure out the alignment. It's not too hard. Okay. So that was the route that we chose to do because like Google Mapbox data was really unprecise, and there was another method which didn't work for us, and that is Google Earth plugins. There is one for Houdini and one for Blender. For some reason, none of these worked. For example, this one for Houdini was generating characters, file names that are 300 characters, and Windows don't like it. So we didn't have time to dive into that any deeper. Okay. Okay, and there is this method. So does anyone know what this is? This on Google Maps, this is empty desert, but in the application for running, I forgot what is the name of the application, some dumb guy was running and recording his tracks, and that's how world found out where is the secret US military base. After that, they were forbidden for using these applications. Yeah, so on the map is not existing. So I'll show you later one of my like R&D projects, but I was obsessed like how should I get more precise map of Belgrade. So these are my tracks of me going to doctor, me going to work. So I was recording these tracks with GPS application. So my hope was that I can use this to actually increase precision of this like shitty Google Map data. And actually this worked, but so I wrote a Python script which would take these GPS tracks and create lines from it. It's not too complicated. It's just parsing XML data. But in the end, what I figured out is that you can do this thing on Google Earth, just draw your paths and export them as a GPX file and feed it here. And it's more precise. Okay, so like the steps of a working process would be something, this is like a vague list of it. Our colleague Nikola from Nordeus, Nikola Damjanov, he has really good courses about how to work with height fields. I strongly recommend diving into that. So basically for us, the first step, because our maps were huge, the first step for us was to divide these maps into smaller tiles. I think for this, for Mecha, it was around 100 kilometers. So you don't want to work on 100-kilometer height field. So I can play it maybe again. Okay, yeah. So these are these chunks, and I use something called tops in Houdini to divide this. Does like anyone uses tops Houdini? No, we should make a course about it. Okay, so the idea is with the tops is, yeah, I skipped this slide actually. Okay, so the idea with the tops is that you have a set of nodes which are run on separate machines. So you design a process and you say, okay, I want each of these tiles to be processed on different machine in the farm. So without it, this would take ages. So that's the beauty of it. So all of these nodes here, I don't know if you see. Okay. Okay, all of these nodes here are run in parallel on the farm. Okay. Sorry. Where is it? Okay. Yeah, so the next step is like primary shaping of your height field. So like usually what we do is we increase a bit details on the height field with distortions and then do several layers of distortions, and maybe like what you see here, this is really good technique that I learned from Nikola, is like you create a pattern and you project this pattern into peaks of the mountains, and then you do erosion. And this like pattern, like this would be like chunks of the rocks that are standing out in the peaks. So yeah, so when you do erosion, yeah, this pattern is noticeable here. When you do erosion, you get more interesting stuff. Okay, so this is like the first step of working. And this is just a single tile. So whatever I design to do on this tile will be run on each one of these, like, I don't know, 60, 70 tiles. Okay. And then, yeah, so then next step was to put some actual cliffs inside of these, to put these assets, to inject them into these cliff faces. So this is the technique that I used. So I'll play it again, don't worry. This was running slower on my machine. Okay, so I divide it into this kind of like Voronoi chunks. Why? Because I don't want, if you divide it in square chunks, you will have some problems blending it later. So the idea was to divide it into chunks, and for each chunk to detect what are the areas with high slope, and then I divide this into smaller chunks, and each one of these chunks has its own area. So what I can do with that is I have this set of the assets, and each one of these assets is oriented in Z positive space, so I can measure the area of each one of these, like facing forward. And I can say, okay, you will go into the cell that has approximate area like you. And sorry, my cursor is here. Okay, so each rock will go into area, into cell which is like a similar area as it. Okay, so that was the idea behind it. Okay, and then what you can do, you can also project these rocks into height fields to alter a height field a bit with these assets, but you are keeping these assets. These assets get rendered, but you want them to affect terrain a bit. And then, this is like my favorite part, and then for each one of these chunks, I run simulation of these rocks, of these like smaller rocks tumbling down. And then, yeah, I think I had I don't know, hundreds of these simulations. They were run on GPU, so there were like a couple of minutes each. And these are these chunks, I import them in Karma and see like, okay, this is the good distribution of these small rocks, bushes, blah, blah, blah. So I could test this small chunk before merging everything together. Okay. So this is like what single tile or package contains. It contains height field, it contains points, and these points have paths to USD assets, and they have which variant of the asset is used. So variant of the assets is like, if you take like 100 rocks from Megascans, let's say, you really don't want to create 100 folders and put each one of them into like as a separate asset. You put it in one asset, and you can basically say that each one of these rocks is different variant. So when you do scattering, it's really easy, like with some random function to vary these. So all of these points essentially link to one or two USD files, but these USD files can have like infinite amount of variance in them. So basically inside of this point cloud we have all necessary information: position of the points, scaling, orientations, which asset is used, and which variant is used. Okay. And then this gets fed, so these are different tiles, and this gets fed into Solaris. And the lecture that I referred on Houdini Horizon Hive, I was explaining there how I built this like importer for these points. Basically, it's instancer. So you can, there is nothing custom there. It's vanilla Houdini nodes. The only thing is I have a point cloud, and let's say this point cloud references 3 USD files. What I will say, what this tool does, it loads these 3 USD files, and then it creates instances for you, so you don't have to do it like again and again. So basically, we have this tool which like you give it a point cloud and it does everything for you, like instancing, orientations, and so on. And in Solaris, in Karma, this is how these instances look. So I think in this scene it was like 30-40 million of this, and it's not slowing down because of that. Okay. So what I do with these chunks afterwards is I project each one of them into height fields, into this like main height field. And here you see like what is the difference before and after. Let me play that again. So this is just a single chunk. This process can be slow because it has to iterate over the same height field many, many times. So this took like 2 or 3 hours to process. Okay. Okay, and this is the other terrain, Jerusalem. So it's the same idea. Like you do primary erosion, secondary erosion, add some details into cliffs, and then you do this slump. This slump is really slow, but it creates like piles of debris based on the mask that you provided. So I will pause at that moment. Yeah, so this red mask, so I'm adding a bit of details into these cliffs, and then when I do slump, you see how like there is like material that was piling for a long time, and this is not erosion, it's called slumping. Erosion creates more like this like water rivers. Okay, and then from client we got this like general layout of the city, so we were projecting these main streets into the terrain to affect it a bit. So there is really cool node in labs. It's called lot subdivision. If you're not lazy like me, you can write it yourself. It's really like it's good exercise for the brain. Okay, so yeah, I got the streets and I got something that's I call this parcels. So parcel is area in which buildings get generated. And for me here, let me play it from beginning. Okay, so how I do it, I have one of these like parcels, and I just stack these buildings in circle around, so there is like a yard inside. And these buildings, this is like this is the part where these buildings get generated. Don't be shy to use building generator from labs. Like it's like you can use it, you can learn a lot from there, and then you build your custom. Like nobody's forcing you to reinvent stuff. So here I was using this like building generator asset. So basically what you do is you provide it with these like sections like windows, doors, blah, 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 and you write the rules. Based on these rules, buildings are generated. And in the end, what you get is, again, you get a point cloud. So for instancing, when you create system for yourself in which you have point cloud, you ingest this point cloud and instance whatever you want. Like you do it once and you have it like for all ages. Okay. Okay, so next. Yeah, so this was for the buildings, and yeah, one tip for vegetation is don't use opacity, never. I think even in Unreal, that's like not recommended to do, or use opacity that is 1 bit, only 0 and 1. In Karma, like if you use opacity on the leaves, your render will take 10 hours. If you don't use opacity, your render will take like half an hour. So that is the ratio. So don't use opacity, convert it to geometry. There are like online, I found a Gumroad tool one guy wrote, which just, you give it geometry, you give it alpha of the leaf and it cuts out geometry of the leaf. In Speed 3, there are tools for that as well, so yeah. Also, what we didn't implement on this project, we didn't have time, is LODs for the trees. Like in the end, we didn't use them, and that cost us. We had like at the time we had 10 or 20 machines with 128 gigs of RAM, and only these machines could render it. So after I like created a system for like loading appropriate load based on distance. Also, one good tip is if you have these like memory issues, render in tiles. So if your output is 4K, you can render it in 4 tiles, and it would consume a lot less RAM. Like it could be difference between 70 gigabytes and 128 gigabytes. Okay. 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 Is anyone here familiar with VEX? Okay. Anyone did shaders in Vex? No? Okay. So back at the time, there was no texture bomber in Houdini, so I had to write it. Okay, sorry. Come on. Okay. Yeah. So. Fuck. The thing with the GIFs is not working. Okay. Yeah. You see this road here? Yeah. This light is very strong. So. The idea was like for me when you do height fields, so the two worst things that you have in texturing is repetition of the textures, and the second thing is like when you do these dirt roads, like traditionally what we would do is we would generate geometry that's slightly offset from terrain, and you apply some texture onto that geometry. Here it's not working like that. Here, inside the shader, you give it this geometry, and your shader actually samples this geometry, samples the UV from this geometry, and basically you get like in gaming terms, this is called decal. So you get roads that are perfectly blended into terrain. This thing in Vex shaders that you can do, you cannot do it in Material X, you cannot do it in Arnold, you can do it in Renderman. So as far as I know, Karma and Renderman and Mantra are only renderers that are able to do this. So yeah, the other issue for us was like when you do terrains, there is like 30 textures that you have to blend. So for example, you have, let's say, texture for the gravel, texture for the grass, texture for the, I don't know, sand. So you do all of your blends for diffuse, for base color. And then you have to repeat this same thing for normal, for specular roughness, for all of different channels. And my notion was like, this is very stupid. Like humans should not do this. And I was watching some tutorials for Unreal. And in Unreal, there you have these like material functions. And I was wondering, like, is it a way? Is there a way to do it? So it's a bit hard to see here, but you see these like orange lines. So these like orange connections. So basically, I created a node in which you feed it diffuse texture, specular roughness texture, normal displacement, and this gets bundled like optical cables. So you have all of this stuff, but it's bundled in one like this orange connection. And then I have nodes. For blending of this. So you blend it with, you use mask to blend, let's say, grass and ground, gravel. So you do it once, and then at the end, there is a node in which you unpack all of this stuff, like diffuse, specular, normal, blah, blah, blah. So you don't have to repeat this stuff in shaders. So in Houdini, this is called structs. So struct can be like your defined data type. So you can bundle these connections into one like master connection. This thing is coming in Material X, but maybe in 10 years. Okay, it's not high on the priority list. Okay, yeah. So you can see on the right, that in Vex shaders you can actually write the code of your shader, which is really cool if you know what are you doing. Okay, so that's about it. And this is my Unreal part. Unfortunately, we had a party last night, so it's very unfinished. Okay, so when Nanite came out, first things that I tried is to create cave generators. So I created this generator which would input geometry, like you model in Unreal with all of its powerful modeling tools. You model like a cave, and it generates all of these for you. And this was total disaster. Why? I was expecting that I can generate like the amount of geometry, like infinite amount of geometry, and that's like one of the things that is part of this like Unreal hype. No, like I generate this cave, I have to close Unreal to open it again for GPU memory to get free. Then it works. So basically, Nanite still doesn't mean that you don't have to instance. You have to instance still. Okay. So that was my first failure project. Okay. So this is a demo that me and Nikola, Uroš, and Marko did for one Japanese client. So they asked us, like, can you do environments in Unreal? So what we did, this is similar like Matrix demo, trust me. So if you want to do this kind of stuff, like my advice is download Matrix demo scene and like just study what they did, because what they did is like these are the best guys from Epic and best guys from SideFX. Yeah, so we managed to create like lighter version of this like Matrix demo scene that we could understand, let's say. Okay, and Nikola was using motion matching for this character, but this is like a typical meta-human character. Yeah, it's very laggy. I don't know why. Okay, so this was like, for me, this was like really encouraging project. And then we had to switch to some of our film projects. So this is on on pause now. Okay. Okay, so I will show you what I generated in Houdini. So in Houdini, this is my scene. So it's a bunch of points, as they did in Matrix demo. So if you like to play Lego, this is thing for you. Okay, and like the logic that I did for these ancient cities and the logic that's done here, it's absolutely the same. The only difference is for Unreal, you give it attribute that's called Unreal Instance, and Unreal picks appropriate asset from content browser, and that's it. Like you just give it point cloud. If the thing is in content browser, it will be instanced, unless your GPU fails, of course. Okay, and this is the latest thing that I'm doing. So this is Belgrade Street Dimitrija Tucovića in 19th century. There was a river there, and this is like a boulevard of King Alexander. And this will be like the old city eventually, when I have time in between projects. So yeah, I'm trying now to apply all of the stuff that I learned along the way in like doing these environments in Houdini. I'm like trying to apply it here on like recreating 19th century Belgrade. And a really good resource if you want to dive into this kind of stuff. There is on SideFX site, there is a tutorial series that's called Project Pegasus. It is like, it is step-by-step guide how to do like large-scale terrains with Houdini engine and Unreal. Okay, and that's it.